This video is about the area of a parallelogram and goes with CPM Chapter 5, Section 3.2 for 6th grade. Before we get too far, there's some important vocabulary that we should review before we go through the lesson. First is parallel. When we talk about parallel, we're talking about two lines on a plane or a flat surface that never meet. You might see it illustrated as this, where we have two lines and then they have little arrows on them to designate it as being parallel. When we're talking about perpendicular lines, we're talking about the distance between two parallel lines or segments where the ends form right angles. And that could look like this, where you have two parallel lines, and then this distance between it's denoted with that little half square to show that they are both right angles. When you talk about a parallelogram, we're talking about a quadrilateral or a four-sided figure with two pairs of parallel sides. And that could be written like this, where you have these two sides being parallel and the base and the top part being parallel as well. And then decompose, that's simply saying that we're breaking something down. You could also look at it as splitting it into parts. Okay, think about the L-shaped rectangles that we looked at in the last lesson. Okay, you could decompose it into two separate rectangles to find the area. Okay, now use that to help you with this next part. Okay, here we have a parallelogram. We did not denote the sides as being parallel, but in this case we're going to assume that they are. Again, in more advanced concepts, you'll need to be able to prove that, but we're not at that point right now. Okay, if we look at this, we can drop a line straight from the top, and that will form a triangle. And that's going to be a right triangle, and we're going to consider that our height of the parallelogram. Okay, if we go from this section all the way across the bottom here, we can call this part our base. Okay, and we have our base and our height, and usually when you're starting in the area, they'll give you different values for each, and you'll be able to calculate it. Okay, and going along with the values, sometimes instead of marking the sides as being parallel, they might say that this is 5 centimeters and this part's 5 centimeters. Okay, that way that you know, okay, it's the same length, and since these lines here are parallel, these have to be the same length. So in the last lesson, we were looking at cutting up different figures and seeing how we can rearrange them to turn it into a rectangle. With a parallelogram, we're able to do that same thing. And what we're going to do is we're going to take this section here and essentially just move it over to the edge here, where we're going to add that triangle across. Okay, our base is not going to change. And the reason for that is this distance here is going to be the same as this distance here. And the height that we have here in yellow is the same as our height in blue. All we're doing is we're rearranging that. So in order to find the area of a parallelogram, all we need to do is find our base and multiply it by our height. Okay, you might recognize that that's the same as a rectangle, and that's because what we're doing, again, is we're chopping off this section, sliding it over, and turning our parallelogram into a rectangle. Use that to answer this next question. Okay, it says to find the area of the parallelogram, and again, they did not denote this as this side and this side, the slanted sides, as being parallel, but you know that they are because they're the same length, and your base and your top are also the same lengths. Okay, which means that these two have to be parallel and the top and the bottom have to be parallel. Okay, go ahead and find the area, and then I'll show you how I did it. Okay, remember we wanted to decompose our parallelogram, so I took this section here and I moved it over to the right. Okay, and again, my base does not change and my height does not change. Then I wrote down my formula. Area of a parallelogram is the same as base times height, and then I just filled it in, where area is 9, which is my base, times 5 centimeters, which is my height, which gives me 45 centimeters squared. And don't forget to square your answer.